Hi, so I'm Loren Gordon. We're going to be talking about a software project that was using simple machine learning to mine fairly complex data, SCCM, inventory data, and NIST vulnerability data. I'm going to start off with a quick overview of the network where this, the production network where this was living and working, and then dive right into the challenges. The one takeaway that I think you should remember from this is the same thing we heard yesterday. Know your data. Get intimate with the data, and that makes the machine learning work really much better. So we're going to talk a fair part of the presentation is going to be talking about these complex data structures, what they are, the meaning, the significance of them, and also the dirty, unstructured data that I had to deal with. And then finally, we're going to talk a little bit about people issues. Always interesting. I'm a technical security architect at Ubisoft. I've worked at a number of other places, major world-class telco, etc. I just have a passion for everything that's technical security. Love it. Everything that I say is my personal opinion. It has nothing to do with my company, of course. Now, the network is a worldwide network. There's maybe 11,000 members right now, team members. They're spread across 18 countries, 26 studios, and it's Windows-centric. The interesting part about this network is that the company encourages creativity, so the developers in the individual studios have their own environment, their own software, and the local IT has a lot of autonomy. This poses an interesting challenge to patch management because then the question becomes, find the panda. Software's moving in, software's moving out, vulnerabilities are being published every day, and where's the vulnerable non-Microsoft software and host today? A great idea. I thought at the time anyway. Microsoft SCCM has reliable inventory data. We already have an agent, we don't need to install another one. And this NVD data has update vulnerability data, maybe not exactly all of the vulnerabilities, but a good significant list of vulnerabilities. And put the two together, we already have the data, let's do some good patch management with it. This avoids expensive licensing because we were using free public software. The vulnerability data became a JSON data flat file feed that was fed into a back-end big data mining application. So this was part of a larger project. And someone told me, this is impossible to do. You can't take the chaotic registry data and actually match it with the formalized structured NIST NVD data. I sort of liked it when someone says that because that gives me a challenge. So let's talk about the complex data structures very quickly, if possible. Microsoft System Center Configuration Manager is the application that people love to hate. It's indispensable for the management of enterprise-scale Windows networks. Has a back-end Microsoft MS SQL database that is very, very complex. There's 1,600 tables in the thing, 6,200 views, and everything is is running in little distributed components, running with WMI tightly integrated into it. There's a quick list, which you can't see, of all of the components, about 50-odd components. They're DLLs mostly, running either as mostly in threads, and there's also some services. They communicate between themselves with flat files that move from disk-based inbox, outbox, and they also use in-core queues. Now, WMI, as I said, is tightly integrated into SCCM. Everything is architected using WMI. Client side, the client talks to the managed host using WMI. The server side talks to the client with WMI. The server exposes a WMI interface so the key objects are available through WMI. The console application for SCCM is the WMI management application. SCCM populates its database using 6 discovery methods. There's 4 that are the target Active Directory. One is SCCM talking to the client, and the last one is SCCM going out into the network. The Active Directory is the one that really interests us most. There's the 4 methods in looking at forests, looking at groups in Active Directory, users, and hosts. The heartbeat discovery is the only one that's mandatory, and SCCM is talking to the client. Hello, are you there? Are you installed? Is everything working well? It pulls in a little bit of data from at that point. This runs every 7 days by default. The network discovery is disabled by default, and that pulls in all kinds of data when SCCM is out in the network, pulling in from DHCP servers, SNMP services, things like that. The thing to understand is that this is true of any data mining thing, garbage in, garbage out. If the Active Directory has data that's extraneous or not reliable, if that's pulled into SCCM, not good. Can't rely on it. So the important thing that I found was to make friends with your SCCM administrator. There's 6 discovery methods. Which methods are enabled in your specific production environment? And what is the polling interval? Is it going and getting it every month or every day? Is the data reliable? His career depends on knowing which data is good and which data is reliable. So it's a really good person to talk to. Also, hands-on exploring. I spent many wonderful hours with Microsoft SQL Studio looking inside this database and looking at the different views. Active Directory can be used also to augment the inventory data. We do this in the tool that we're going to be releasing at the end of the presentation. Also, Google is your friend. And Safari Technical Library has a number of good books on SCCM, and there are things, one book especially has good SCCM internals. To get at the SCCM data, the best approach is to query the SQL database directly, not using WMI. This is simpler, more direct, and probably the performance is better. Also, I learned that you have to go after the views and not worry about the tables. The views are more stable, they're documented, better documentation. The community works with the views, and the permissions are already in place. Also, if you go after the table, you can maybe lock the production database, and you're not going to make friends with the ops people if you do that. Microsoft also has done some heavy lifting. They have some stored procedures that they distribute, and then that populates other data into the views. So the views are the way to go. We can see the WMI influence in the SCCM views. The WMI class name becomes the SCCM view name. It's truncated at 30 characters, but you can still see the actual views. The property names are the column names in the SQL views. The column names have a 0 appended afterwards to avoid conflicts with reserved words. The inventory data that SCCM gets from its inventory discovery has v_gs, and the discovery data is v_r for the scalar properties and v_ra for the arrays. There are also views that have metadata about the other views. For instance, schema views list all the views and which ones, how many there are. One of the important views is the views that give us the software. And the one that turned out to be the useful one out of all of the 6,000 was, there's actually 2. There's VGS, add remove programs, and add remove program 64. Be careful because there's another set of data that WMI pulls in. This view is populated from the uninstall keys that go into the registry. There's another set of data that comes from programs that are installed with the Windows installer. So that's a subset of all of the installed software. We're looking to do patch management, vulnerability information. So this gives us a much more complete view of all the software. There's also collections. Which view do we use to find the host? v_vr system is the one to use probably in most situations. It populates from all the different discovery methods, and there's about 60 columns in that view. Very, very useful. The VGS system, as I was hitting these different things, I was wondering, should I use the one or the other? They both have software information, the system information. It only runs when the hardware inventory runs. So that means the agent has to be there, has to be installed, has to be active, and it's less accurate for those reasons. And also the discovery only pulls in about 10 fields. So basically it's a no-brainer. VR system is the one to use. The NIST data, that preceding section was fairly hard to find all that information. I have some references at the end. I'm going to put these slides on the internet for your reference. The NIST data is fairly well known. It's formalized, structured format. The stable version is XML. They also have a beta GSOM version now. There are two main NIST data sets that we want to look at. The first is the CPE, which is a list of all the vendors and products. It's a one file that lists all of those. And also the CVE, which is there's one CV file for each year and has the list of all the vulnerabilities. So here, let's take a quick look at the CPE file. It starts out with a header with the version and date. And then here's a typical item. The first thing that you see on the top is the title. It's a human readable description of what the product and the vendor. And then the CPE item is the one that's interesting because it has all the structured formalized data. We'll go through it very quickly. First is the dictionary version, and then the part what NIST calls the part number. The A is for application, O is for OS, and H is for hardware. We only are interested in the A's. Then the vendor, the product, and the versioning. And if the vendor has this kind of versioning, the updates, the service packs, the minor versions. This particular item was for a WordPress plugin. I specifically chose this one so that you can see that the installed software, the target software, is also mentioned in the description. Now the NVD is a list of vulnerabilities. There are three separate, in a typical NVD entry, there are three separate parts. There's the CVE, which is the basic vulnerability information, the CVSS, which has the impact information, and the CWE, which has the augmented vulnerability description. Let's take a look at the first. This is a typical CVE entry, NVD entry. First piece is the CVE, and we see the CVE ID, which specifically identifies this vulnerability. It's been all tagged and named by NIST and MITRE. And then the CPE entry, so that the vulnerability entry is pointing back to the vendor product information from the CPE file. The second section is the CVSS, which has the vulnerability impact. We see that this particular vulnerability is a network access of medium complexity, and if it fires, it's going to completely compromise integrity. The last section is the CWE, which has HTTP references to the vulnerability findings, and also a description of the vulnerability in human language so that we can understand what it is, what it does, how it works. The CVE data is available as a daily feed I mentioned. We pull in the tool the XML because it's a stable format. It's available as a compressed gzip or zip, and there's a meta file that they give too. The meta file has the SHA-256 hash and also the file size so that you can take a look at, pull down this little meta file and then find out whether you should pull down the full feed or not. Okay, all of that was data so we can understand the complexity of the data. Now, how do we get the vulnerability data out of SCCM and match it to the formalized NIST vendor and vulnerability software data? First of all, wise choice of tools is important, and secondly, a divide and conquer approach was the key to success. The tools, as the usual suspects, Python, Pandas, Scikit-learn, Docker, Ansible. The basic approach was keep it native, first of all. I used Windows to talk to Windows, SCCM, and Active Directory, and that simplified things. And then Linux for the more Linux-friendly things like Docker, Pandas, Path, and Scikit-learn. Also, we only looked at third-party vulnerability software. In our particular environment, that's what really interested because I have a whole bunch of it. And the Microsoft vulnerability left Microsoft to manage that stuff. The divide and conquer approach was basically match the vendors first of all, and then match the software because each vendor has his software list of software. So there's software. Each vendor in the registry will have a set of installed software. In the CPE data file, it's the same thing. There's a vendor, and he has a list of software. So we get the vendors right, and if we can do that fairly accurately, then the software becomes fairly easy to match. So it becomes two separate, simple machine learning classification problems, essentially. And the data is small. It's not a big data problem at all. It fits in one PC. It can run in one PC. So the data can be manually labeled. This is a match, this isn't a match, this is a match. Very tedious, but really useful. And the features were extracted using fuzzy data matching and string length. So here's some sample vendor data. We can see the registry data from SCCM is all over the map. There's capital, different cases, words that make that don't help us, like LLC, all kinds of different variations of names. The CPE data from NIST is very, very formalized, structured, and terse. And the challenge is, first of all, to match these two data sources together. Also in the registry data, the vendor can have up to maybe 5 or 6 different names. For instance, Oracle has 6 different, in the production data I pulled just before coming to the BSides, there was about 6 different ways of naming Oracle in the registry data. So the basic approach is standard machine learning, tokenization, throw away the stop words, and then pull out the features. Tokenization had to be careful about separators to split the thing properly into tokens. And we're also dealing with different languages, it's Unicode. And so we had to watch which exact separators we use to get the proper tokens. The stop words are words that don't add anything to the matching. Things like project, software, limited. So you basically, when you find them, you throw them away. Liebenstein or edit distance, this is the basis of fuzzy matching, is the number of single character transformations, add, remove, or change to get from one string to another. And there's a very nice package called Fuzzy Wuzzy, which calculates simple ratios, whether it's the 2 strings are simply a match or whether one is a subset of another. It takes a look, it breaks the strings into tokens and takes a look at sets of tokens to see how well the matching is. So we use all of these ratios in the tool, and that gives a very nice feature set. Also, we use a string length of the different names. Observations, as we were labeling the data, realized that, as I was mentioning, matching the vendors accurately is crucial. If we match vendor A to vendor B, the software is just not going to match. Also, the data set set size is small. There's only about 10,000 vendors altogether. So it's something we can actually go into the vendor data set and start manually labeling at least the vendors that we think are important, and a lot of them. And this really helps to drive the accuracy up. Because, of course, you use the manually labeled data as well as the machine learning classified data together to do the final vendor matching. Which algorithm do we use? Well, we use simple k-folds cross-validation, obviously. This is splitting the training data into k sets, and then you use k-1 sets to train the algorithm, and then validate the algorithm's performance against the labeled data, which is the set that wasn't in the training set. And you rinse, repeat, and then repeat that for different algorithms. Gives you an idea of estimator accuracy. No surprise, random forest classifier was the best, one of the best, and this is essentially a randomized forest of the decision trees, and the estimator is the average of all the separate trees. To tune the algorithm, again, a randomized grid search with cross-validation is what we did, very, very simple. The randomized search is basically defining different parameter values or sets and then doing a search, a randomized search, and then using cross-folds validation for that. The software matching came out to about 98%, which is about what you would expect from randomized classified forest. And that was the machine learning piece. The interesting thing that we found, though, is that there's also there's a ton of dirty data, and the data wrangling was the other aspect that surprised me as not being a data scientist. Active Directory had about 8,000 extraneous hosts. SCCM doesn't manage everything. Laptops disappear from the network. The versioning in CPE varies wildly from vendor to vendor. Java was the worst example, and Unicode also was a challenge. So we spent lots of hands-on time with the data, use defensive coding, obviously validate all the input, tries, missing data, initialize the missing data or get rid of it, otherwise causes problems, and get rid of the extraneous data as fast as we could. The Microsoft data that we're not looking at, the deprecated NVD entries, etc. Then we discovered also that heuristics was really useful to speed up the matching and make it more accurate. For instance, if a CPE vendor was only 1 or 2 characters long, we throw it away. If the first word of the CPE vendor string would have to be in the tokenized registry string, and then that means it was probably a match. If it wasn't in there, it was probably not a match. For products, we had release information on both sides, so we had to see at least a partial match between the release information. So by cheating a bit, that speeded up everything and also made it much more accurate. When all else failed, code around the obstacle, the Java versioning, we just had to do code to do that. The people issues, just talk about that briefly. Surprising if I wasn't expecting this. Took my great idea to the ops team. The ops team were kind enough to meet with me. We had a conference, an on-site meeting, and the most important person was the ops architect, was over 6 time zones over, was the end of his day. He speaks French and the meeting was in English, so you can imagine what happened. And he's the man in the wall, of course. He's on conference call, so it's, oh, I'd like to say that. Everybody else is having a grand old time. And so it was disastrous. I talked technology instead of presenting from an ops point of view. The SCCM architect sort of didn't connect, and everything sort of died. And then the VP came to town. He heard the presentation, he loved it, blessed it, wanted his dashboard for yesterday being a typical VP, and it had to cost nothing and take no resources. The ops people rapidly became concerned with all of this because they're going to have visibility at Class C level. They started making noises about SCCM production database performance, and this was totally understandable. Instead of doing direct production access, they suggested I use a secondary non-production DB that they use for reporting and query. This is a nice little siding they were going to shut me off on. It turned out that this data underwent arbitrary ETL black box transformations. The data from the production went into the database and made nice reports. So I eventually decided, convinced them that that was not the best idea. To get around the people solutions, hack people, it's not easy. First of all, we operated in pirate mode, the garage project, typical garage project. So running under the radar, Docker, using Docker, moving from Ubuntu to CentOS to Windows, running on laptops, scrap PCs, anything we can get our hands on. Make deals, sell your grandmother to the highest bidder, anything to get that precious production access. And then deliver quietly. We're telling the VP, oh, it's not ready yet, slow it down, downsell it. The status, new technology, we're not sure about the reliability of whatever, And then give at the same time target ops training so that the ops people, they're dump truck people, and we have to help them to understand that this newfangled airplane is not a dump truck, and how to use it, and give them ways to use the new technology and have control over it. Some motherhood lessons learned, and that is about my time and also the presentation. There's my contact information. The tool is on Docker Hub and also on GitHub, Vulns. You can get me on Peerlist, Lorgor77, and I'll be happy to chat with anyone as long as people want to chat with me after the presentation. So I guess that's it. Thank you very much.